Welcome to The Explainer. Today, we are diving deep, and I mean literally, into our planet's most defining feature, its water. We're going to explore the vast, dynamic system that shapes our world, from the deepest oceans all the way to the clouds above our heads. You've seen the pictures, right? When you look at Earth from space, our home isn't really green or brown, it's blue. They call it the blue planet for a very good reason. But what does it really mean to live on a world that's so completely dominated by water? Well, the answer really starts with this number, a staggering 71%. That's how much of the Earth's surface is covered by water. It's absolutely everywhere, in our oceans, our rivers, our lakes, and even locked away as ice. So, when you take all of that water, and I mean all of it, the liquid in the oceans, the solid ice, the vapor floating in the air, you get what scientists call the hydrosphere. It's basically the planet's entire water domain, all bundled together. Okay, so water everywhere. Simple enough, right? Well, not exactly. This is where the story gets a lot more interesting, because just because water is all around us, it doesn't mean it's all the same, and it definitely doesn't mean we can use all of it. The reality is actually pretty surprising. So that brings up a really basic question. If our planet is so wet, where is all this water, actually? And let me tell you, the answer is way more complicated than just saying it's in the ocean. And here's where that breakdown gets fascinating. Take a look at this. Over 97% of all the water on Earth is in the oceans. And, of course, it's saline. It's salt water. Everything else, all the fresh water in the ice caps, in the ground, in lakes, and even in the air we breathe, it's just a tiny, tiny fraction of the grand total. This chart really drives that point home. See that huge blue section? That's all the salt water. And that little tiny sliver, that little slice right there, that represents every single drop of fresh water on the entire planet. It's kind of shocking when you see it like that, isn't it? So let this sink in, because this is the crucial takeaway. Less than 3% of all the water on our so-called blue planet is actually fresh. And here's the kicker. Most of that isn't even in our rivers or lakes where we can get to it easily. Nope, it's frozen solid, locked away in ice caps and glaciers. That has massive implications for everyone and everything that depends on it. So you have to wonder, right? With such a tiny amount of fresh water actually available, how does it get spread around the globe to keep everything alive? Well, the answer is this magnificent, perpetual engine that nature has been running for billions of years. It's called the hydrological cycle. And honestly, you can just think of it as nature's ultimate planet-sized recycling program. It's constantly moving water all around us, above us, below us, and right here on the surface. Now, it might sound super complex, but it really just boils down to three main stages. First, you've got evaporation. The sun heats up water and turns it into vapor. Then, that vapor rises, it cools off, and you get condensation. That's how clouds are formed. And finally, you have precipitation, when all that water comes falling back down to Earth as rain or snow or sleet. And this is what it looks like altogether. You can see the whole system working in perfect harmony. Water evaporates from the ocean, it forms clouds, it rains over the land, and then that water flows in rivers right back to the sea. It's this beautiful, continuous loop that literally powers life as we know it. You know, there's a quote from our source material that just nails it. The hydrological cycle is an endless process. It has no beginning and no end. It just is. It's a fundamental rhythm of our planet that makes everything else possible. So now, let's zoom in on that massive 97% we talked about. The ocean. And let me tell you, it is anything but a calm, static pool of water. No way. It's a world in constant, incredibly powerful motion. Okay, so we're all familiar with waves and tides, right? But what you might not realize is they're caused by totally different things. Waves, well, that's just wind blowing across the surface of the water. But tides? Tides are something much, much bigger. That's the rhythmic rise and fall of the entire sea level. And here's why that happens. It's all about gravity, the moons and the suns. When the sun, moon, and Earth all line up, their combined gravitational pull creates those extra high spring tides. But when they're at right angles to each other, their poles kind of fight against one another, and you get weaker neap tides. Pretty cool, huh? But there's another type of wave we have to talk about: a tsunami. The name is Japanese for harbor wave, but, and this is super important, it has nothing to do with wind or the gravitational pull that causes our normal tides.
No, the real cause is something way more powerful, a massive, sudden displacement of water, usually from an earthquake or a huge landslide on the ocean floor. The energy that gets released is just immense, creating a wave so powerful it can travel across an entire ocean.
So we've got waves and tides on the surface. But deep down, the oceans have these enormous rivers flowing inside of them. We call them currents. And these are just a few of the big ones, both cold and warm, that are constantly circulating around our planet. And this map shows you exactly what that looks like. It really is like a giant global conveyor belt. The warm currents, shown here in red, carry heat from the equator up towards the poles. And the blue ones, the cold currents, bring that cooler water back down. This whole system is one of the main drivers of our global climate, influencing weather everywhere. So, okay, the ocean moves. Big deal, right? Well, yeah, it is a huge deal. These movements are what regulate our climate and weather. They're what sailors use for trade and navigation, and where warm and cold currents meet, bam, that's where you find some of the richest fishing grounds on the planet. Not to mention, they support countless ecosystems. And that really brings us to the big takeaway here. From a single drop of rain falling from a cloud to that giant ocean conveyor belt circling the globe, the hydrosphere is one single, deeply connected system. So, that leaves us with a pretty critical question to think about. If it's all one connected system, what does that mean for us and for our future on this blue planet?